Good morning, everyone, and welcome to this first session this morning. Just a couple of housekeeping notes before we start. If the fire alarm goes off, out whichever door's nearest, quickly, is the idea. If I could ask you all to put your mobile phones, Blackberries, iPhones, iPads, and whatever else you've got, either switch them off or put them onto silent, please, because they do have a horrible habit of interfering with the sound system. And also, we'd be very grateful if you could complete any feedback forms at the end of the session, just so, so we've got a good feedback for the sessions we can put together for next year, just to make sure we're addressing the things that are of our interest. So, without further ado, it's my pleasure to introduce Shaun Walsh, who's the Senior Vice President of Corporate Marketing and Development at Emulex, and he's going to talk to us about the megatrends driving the data center for 2016. So, Shaun.
Thank you. All right. So, I do like these things to be interactive. Con here knows me. I am from California, and just so you remember, in California, we share our feelings. So if you feel strongly about something, just let it out. All right. So, what do we mean by megatrends? So, these are sort of macro type things. We're looking for stuff that talks about how do we see change happening? What are we talking about? So I'll give you an example. Gartner just put out a report on some of their big changes and things that they were talking about. Now, when we talk about what's changing in the world, one of the things that we'll talk about is the Internet of Things. So all of the devices that we carry that do all these various tracking, GPS, generate all this data about us. And how do we connect it? How do we keep it together? And one of the things that I thought was the most fascinating thing out of this report was they said, imagine that we're going to have RFID ink that you can put in your tattoos. So you can just wave your arm over stuff, and it'll automatically pay your bills. You don't even have to carry a phone anymore. They're just going to embed it inside you. I'm like, that's a scary trend. So what do we see happening? And this is kind of why I'm talking about this, is data is evolving. So we all know about the metadata that you have on your disk drive that says, here's how big the file is, here's what type it is, here's how the associations we want with it. But we're going from a place where it's driven by applications. We've moved into location-centric, which is obviously what we have with our phones. And then we're starting to add contextual. So it knows not only where you are, but the time of day, what type of network you're running on, and what type of data can be delivered based on the applications that you have. What's the type of consistency of packet delivery that you need? And these pieces of data are going to continue to change how you deploy stuff. When you talk about the data center, there's really two big segments of the data center that are emerging. If you look at how the web is being deployed, things like Facebook's Open Compute, Google data centers, we all see the pictures. We all like them. You know, they show these great big massive data centers. That's one side of where the information infrastructure is going. The other part of it continues to be classic IT, where you're seeing virtualization. The difference is you've got VMware and lots of other stuff happening here. When you get to the cloud, it's kind of the opposite. They're using various forms of Linux. They're using massively parallel applications. They're not delivering things in the same way that the classic IT data center is. And it's this schism between these two classes that are changing how we develop products and how we see products being developed. And then you've got this ground in the middle, which is this hybrid data center. And when you talk about that, we don't know what that is. We're all trying to make that up. Okay? And I think that this is going to be very much one of those things where it's determined by everyone's need, because we don't know what it is. And as you look at what's happening with networking, what does this mean? Well, it means that you've got to have networking that's very, very flexible. And one of the reasons that we're such a proponent of the whole software-defined architectures that are coming up is because of this reason. You just don't know. There are good practical reasons for flattening the data center, lowering cost, lowering power, those sorts of things. But when you think about it from the different scales, from the virtual data center to the hybrid to out into the cloud, you've got to have the flexibility in the architecture in order to deliver each of those classes of service. And then when we talk about the web, there's really three classes of service. You have the massive application, one app to millions of people. You've got sort of this middle ground where people are doing things on Force.com and they're doing various types of mashups and that sort of thing. And then you've got infrastructure as a service, which I believe used to be called co-location and co-hosting, but we put a nice new label on it so it fits in the diagram. And then from the storage side, we're seeing the classic, as I like to call it, spinning rust move up into flash. And by the way, I put big data in here because it's been classified as a storage technology. I'd like to state for the record, it is not a storage technology. It is a sorting technology. Happens to use a lot of data, but it's a sorting system, not a form of data. So where do we see the trends? Virtualization we've talked about. Global cloud delivery. Let's see, I think this was IDC data, but they said basically 90% of all new data in the world from mobile devices. It's IP-driven, not block-driven. Now, I happen to work for a company that sells a lot of block storage stuff, but it's one of the reasons we got into the 10 gig market, because it's all going to be file-based as you go forward. The second part of it is, when you look at these devices, they're going to go from 1 billion users to 3 billion users over the next couple of years. One of the fascinating data points I got out of one of the Cisco books is that they estimate there's 150 million people in the world right now that have web-enabled mobile phones that do not have power and water in their physical houses. I mean, when you talk about the ubiquity of connectivity, I think that's a pretty powerful statement. Big data we've talked about. Converged networking, I have to put that up here because I work for a converged networking company. That's my shameless plug. Cache storage. This is probably one of those fundamental pieces that's going to change how things are deployed. We're seeing it happen at every level. And the part that I think is fascinating is we already have tiering inside this between pure zero, sort of tier 0 memory, SSD with RAM, then flash, and the different characteristics. But behind all of this, you got to connect it. And you're going to see a lot of changes in terms of that as we go forward. So, John, this is for you guys. Shameless ripoff from Intel, from your investor deck. And where are we seeing things change? So the enterprise as we know it, yes, it's growing, but look at the ratios of growth, okay? Public cloud, going to be somewhere around 25% of all servers shipped in the world. Now think about that. That means that the SMBs and all these other places are going to move to cloud-based types of services. That's where we see the big change. High-performance computing, all the weather modeling. I'm sure the folks in New York wish that we had better weather modeling in terms of telling them where this was going to go. Workstations, pretty stable. But look at enterprise storage devices based on x86 as well as networking. This is one of those things when we talk about leveraging software-defined capabilities. This is a great example of it, because you're taking relatively generic platforms, adding a little bit of sauce to them, and you're getting the different pieces that come out. And in terms of growth, the BRIC countries, I realize they've gone from 30% growth to 10% growth, but compared to what's going on in the States and Western Europe, this is way ahead of the curve. And you're seeing the emergence of local OEMs. I forget how many years ago, but it was like 3 years ago. There was none. Lenovo, Huawei, Sugong, they didn't even make the list. And now they're in the top 10 of server providers. And the interesting part is probably the biggest service providers are folks we don't know. It's Wistron, it's Foxconn, it's these guys that are building these things on contract for Google and Facebook and the other folks that are part of this public cloud number. So when you think about what's happening, there's a huge transition in terms of what's going on in how IT is delivered to the world. So when we talk about this, what do we mean? 100 billion data drivers. So 3x in terms of internet users up to 3 billion. 100 billion things in the world with RFID tags running around, not just human beings. Think about that. How many IP addresses do you need to deal with that? We may need IPv7 or V8 or whatever they're going to call the next one. And 90% of the data is video and pictures. How do you sort that? How do you categorize it? How do you make sure that it's delivered consistently? Virtualization, again, this is all about mobility in terms of where you're going. So 70% of the new servers that are being deployed in IT and SMB are virtualized out of the gate. And if you're going to have hybrid cloud, you've got to be able to vMotion it. This is where the technologies like VXLAN and NVGRE from VMware and Microsoft respectively are needed. And the best part is, all they do is they turn it into VPN between the data centers. And that's really what we're talking about here. But the other nice part about it is this scales the number of IP addresses. So there's a couple of white papers on our sites that talk about that. But this is one of the things that is going to change how the IT segment is deployed as we go forward. The other advantage to this is that if you're an infrastructure as a service provider right now today, you typically own the networking infrastructure. But the actual boxes in the rack are usually dedicated leases. And you're losing money, you're burning power, you don't have a lot of efficiency. The big advantage to this is it provides the right tools for doing multi-tenancy. And just like Fibre Channel had zoning and masking and things you could do with MPIV to segment that, now you can do the same thing on the networking side and do that dedicated from private data center through public and co-host those applications on the same server. The efficiency and the scale will help drive the cost down. Then when you start talking about what are some of the other tools that are helping here, things like SRIOV, which is Single Root I/O Virtualization, another acronym that we've invented that no one else will ever remember. But the whole point of this is you can create lots of virtual NICs. And when you can create virtual NICs, then you can allocate them. And again, this goes back to the sort of whole software-defined infrastructure model that we expect to see going forward. This is one of my other favorite charts, VMs per server. This is probably one of Intel's favorite charts too, because it means you're using lots of CPU cycles. But did this work with Enterprise Strategy Group. It used to be about 10 VMs per server. They believe the number is up to 24 and will scale to 100. Now, how do you deal with the manageability of these? How do you make sure that different VMs aren't stepping on top of each other? How do you make sure that you can move these back and forth in and out of the cloud? And what do you do if one of them dies? How do you back them up? How do you reallocate them? These are all the challenges that the folks out here on the floor are talking about. When we talk about what's going to change, imagine compute density quadrupling over the next 4 years. This is why you're starting to see things such as microservers and things that can really, really scale the I/O density in the same square foot. So when we talk about the cloud market, there's a whole bunch of different players that go here. And this is kind of the hierarchy that we expect to see in the world, is you'll have the high-end SaaS folks where you've got billions of people accessing mass applications. And the interesting thing about this is when you look at how these guys are deployed, a lot of these guys don't actually have their own data centers. You know, one of the things that was interesting is we went and we visited, I don't know if I can say this publicly. Well, they'll yell at me later. We went and visited Salesforce.com. We were thinking, hey, big data center, we can sell them lots of stuff. We went and talked to them, and they go, yeah, no, we don't have any servers. We just write software. We don't do this stuff. And that was kind of a really interesting thought. These guys don't believe they have to own their data centers. I mean, that's a pretty fundamental shift in terms of how people are developing companies. And I think when you talk about where is IT innovation going to come from, it's going to come from people that are developing applications and services that never own anything. It's going to really change how we do things. The platform as a service model, I think, is the most underrated part of the trends of the future. Why? Because that's what's going to enable these guys to create mashup type applications, to write a very small amount of code, but uniquely deliver a value proposition in the market. So whether it's GPS driven, whether it's community driven, whether it's social media driven, you don't have to own an infrastructure to build a company. You don't have to own an infrastructure to deliver a value proposition. All of the tools exist, and it's a question of how you assemble the Legos, and do you do it in such a way that it adds value to people's lives. On the infrastructure as a service side, you're going to see this change from reasonably dense to incredibly dense. We can't continue to scale the power and the cooling OpEx challenges that we have right now as we go forward. So these guys, folks like Savvis in particular, are really driving that forward. Private cloud will mean anything that anyone wants at that point in time. And then you'll see the traditional data center continue along. And, again, I'll use Emulex as an example. The first question that our IT guy asks when we ask for a new service is, can it be done in the cloud? Because he doesn't want to own the servers. If it can't, or there's a security reason or a policy reason, and I think that's going to become the big dividing line, is what is the regulatory policy issues as to whether it's in or out of the data center. And how do we see this changing? Well, Google gets a lot of credit in the world for they've done everything on their own. They've designed their own servers. They've designed their own S. They've designed their own file system. Well, most mere mortals can't do this. And most of them don't want to. They don't view it as a strategic differentiator in their business. And that's why you're starting to see this open up. So you're seeing the CentOS and the Red Hat go to Ubuntu and other types of Linux distributions that give them a little bit more stability in terms of back-end backup and development tools that they need. You're seeing internal management tools going into things like OpenStack. And when you talk about software-defined infrastructures, VMware used that term at VMworld this year as sort of their next generation in terms of what they're looking for. And I see OpenStack as one of those very similar in principle drivers. But what we're seeing is that the ability to have open source and drive that within a framework, not just a pure cowboy environment. The whole software-defined part in terms of networking, this is all about optimized delivery and low latency. So we all know why TCP/IP is out there. It gives almost everyone 80% of what they need. Everyone on the planet knows there have been better technologies that have come along, and yet Ethernet always seems to win. Why? Because it's just good enough, and it has the right cost basis to make it work, and it's ubiquitous. And what we're going to see here is people leveraging that physical infrastructure layer, but changing how it's delivered. So we've been working with some of the folks at Stanford and Carnegie Mellon on what they're calling data center TCP, which gets rid of some of the latency. Okay, they have another. Stanford has an architecture that they call HUL, or high performance, ultra low latency, and it's about removing those pieces from the stack. It's about basically creating a layer 2 capability inside a layer 3 shell, and you'll see that as a core trend as we go forward in terms of how people will change and leverage IP going forward. Obviously, the open compute stuff gets lots of hype. One of the interesting things for us is when you look at these data centers, you have the front end massive application delivery stuff. Then you've got sort of the Hadoop sort, cert, no SQL layer, and then you have the part where they actually collect money at Facebook and Google and all that. All the part where they collect money, it's still on Oracle and standard x86 and fiber channel backends. You get a lot of hype on the other end. And we've actually started using the term that fiber channel is the Swiss banking of networks at this point, because they only use it for the money going forward. Everything else will be driven by IP. And again, in terms of the big data stuff, you're seeing the Hadoop distributions come out, and we are seeing the trend of 1 to 10. And this is very application specific. I don't want to say that people are just going to 10 blindly. Okay. If it's a web search request from your iPhone, that's going to be on 1 gig for a long time. If they're doing content delivery and 50,000 people want to see the cute puppy, then that's going to probably be delivered on a 10 gig pipe. But again, that 10 gig pipe is going to get divided in 1,000 different ways. It's not about the raw bandwidth. It's about how that bandwidth can be delivered and applied. I'm a bit of a car nut, and one of the things that I always have this argument with people is it's not about the horsepower, it's not about the torque, it's can you put the torque to the ground? And I think that's when you talk about how networking is going to change, that's what we're talking about, is how do you deliver and make that bandwidth usable to the people on the specific application they're looking for. So this was a fun one. We had a debate, and have you ever had an argument with someone and then opened your mouth and discovered, oh crap, that's my boss. I shouldn't be arguing with him. And he said, you know what? I think you're wrong. Go get me some data. So we actually went and talked to most of the prognosticators and said, where is big data being used? And they kind of mumbled, we don't know. So we have a database of roughly 2 million end users that over the years have registered for fiber channel drivers and crap. So we sent out an email, promised everybody a Starbucks card, and we got about 2,000 people who actually responded to questions on big data. And this was the part that fascinated me. The people that are using it, 5% on search, 6% on social media, 11% on web. Less than a quarter are using it for web. What are they doing? Well, they're extending the data warehousing model into this paradigm. What was the number one thing that they were using it for? You bought Oreos last week. And everyone who bought Oreos also bought milk and peanut butter, and they must have kids, so we're going to put the fruit juices next to them. It's about product placement. On the financial applications, when we drill down into the people that were doing it, you know what they wanted? They wanted people who carried high credit card balances, but always paid their bills. And they wanted to find that sweet spot of people for maximizing revenues. Security, you don't want to know what they were looking for. If you think you have any privacy left, it's just a question of whether they bothered to look. So there is no longer privacy, there is delayed ignorance. And then, the scientific stuff was actually pretty cool. We were actually talking to one of the end users was working on some research, and it was looking at how you do cell regeneration and different things for regrowing corneas and stuff like that if they've deteriorated. So there is actually, you have the good data and the bad data. So we said, what does big data mean to you? Well, they said, look, about half the folks said it's going to force us to double our bandwidth. Now, this is one of the more interesting pieces, is if you look at how bandwidth is being used, and this goes back to that layer 2 bubble inside a layer 3 architecture, it's the east-west traffic that's growing. I mean, overall, it's growing, network traffic is growing about 30% according to IDC. But the east-west traffic, back and forth between systems, is growing at twice that rate. And this is the types of applications that are driving it. Roughly 60% said it's going to grow their storage by 50%. About 20% said it's going to grow it by 100%. Just what you need. Another reason to double data. Storage administrators in the room, you have a job forever. Forever. You will never, ever be out of work. This is a slide I just threw in because I thought it was cool data. All right. So first off, how many people know what a zettabyte is? Those of you who don't, I actually had to go look it up on Wikipedia. So apparently it is 10 to the 21st. If you haven't guessed, that's a lot of damn data. So we're going to go from 1.8 zettabytes to 8 over the next 3 years. All thanks to cute puppies and drunk people at a bar who shoot video. You laugh. Look at YouTube. All right? Digital videos and images will be about 90% of it. Cable companies, if you're out there and you're not doing IP TV, you're probably dead. Find a new job. It's all going to move to SSD of some flavor or flash or whatever. Last time I said this in a room full of people, I had 6 people tell me, no, it's not SSD, it's flash. And then the flash people said, no, it's SSD. I don't know. It's all memory crap. That's all I care about. And that Big data is going to get bigger. Why? Because Big Brother wants to know what you're doing. Some of them want to know just because they're nosy. Some of them want to know for legitimate reasons. But most of them just want to sell you more crap. All right. So Flash. Why is Flash changing everything? Well, it's like everything else that we've ever done in this business. As soon as you make something faster, you create another bottleneck. And it also has to do with latency. Our expectations on response time are unrealistic. Okay? I don't know if this joke will translate in Germany, but in the States we've diagnosed all our kids as having ADD or attention deficit disorder and all these other stuff. We've got them all on Ritalin and I don't know what the other one is. I don't know. There's a couple of others. So in theory, you give the Ritalin to the hyper kids and it calms them down. Okay? But the kids that are studying for tests in college are taking it because it hypes them up. And that's what we're dealing with in Flash. It's the Ritalin of the computing world. And when you put it in the server, the applications run really, really fast. And guess what? Then the networking has to change because TCP has too much latency in it. That's why you're starting to see software-defined networking. So that it can go, oh, you're running this hyperactive application? Let's load the hyperactive driver. Okay? And that's the part that's changing. And now if your server runs that fast, what does your back-end network have to do in order to feed it? Okay? If I'm running SSD flash and I now have my storage in DAS and I want to vMotion a system, how do I vMotion that where the VM moves in half a second, but it takes me 20 minutes to copy the data because it's a terabyte file? And I got to go up through the stack and down and out Ethernet or out fiber channel, copy it to a back-end system, then copy it from there up into the new one. You got to fix that problem. At every single layer of the architecture, this is changing things. Everyone likes to talk about Facebook and iTunes, but you know what? If I'm the new guy in India and I just came up with a great new idea and I'm going to build a software company and I want to deliver my application globally, I want it to look and respond just like Facebook and iTunes because people have attention deficit disorder. That's why CNN is having the success they are, because they put little tiny sound bites together. Of course, come to think of it, that's kind of how we pick a president, too, in the States, which is equally disturbing. I hope your level of politics is better than ours, because it's really sad. No? All right. So we also did some a little bit more survey work in terms of some of the other pieces that we're seeing. So this is obvious. Bandwidth is going to grow as a result of this. Okay? The data center is growing. Convergence is starting to happen. And we're going to see bandwidth grow up to 100 gigabit. Why is that? There's more crap on the web. There's more data. You go from 20 VMs to 100 VMs. And again, it's not about the bandwidth. It's about how you segment it and deliver it and how you allocate it. And you're going to see a period where these things coexist. Now, this is where blade servers are one of the best things for solving this problem. Why? No optics, no extra cables, all done on the back end mid-plane. There's a lot of goodness that goes on in this. So what's the big change in terms of the networking? Again, this east-west traffic we've talked about versus the north-south traffic. Okay? This is your classic in and out of the data center, your cloud, bring your own device to work. This is all the stuff that crunches the delivery of this. Did I actually leave that in? Oh, this is my obligatory pitch stuff. Sorry, guys. I actually thought I deleted this part. Although this one chart is pretty cool. So when we started looking at all of the stuff we just talked about, one of the things that we said is, look, you're going to have a common infrastructure on Ethernet. And for a company who has 80% of their revenue on fiber channel, that's a hell of a statement. But what it means is that the interfaces at the cloud, the interfaces on telco, storage, and data center, each of these things have to migrate. And that's kind of why we put these little dots and conversion in here. Because in every one of them, it's going to be a different type of protocol. It's going to be a different delivery mechanism. And this is what's going to enable all of those other pieces that we talked about. I'm actually going to skip that. So where do we think some of the interesting stuff that's going to happen over the next couple of years? All right, software-defined services. This is going to be not just about networking and servers and virtualization. It's going to be about everything. You're going to have a very flexible hardware infrastructure, and those who deliver the best software-defined services and let you dynamically pick what you want and let you mash those tools together in a Lego format are going to be the ones that win. Hybrid cloud, don't really know what it is yet, but you better make it easy to implement. Does anyone have a definition of hybrid cloud? I haven't figured that out yet. No? Okay. 40 and 100 gig performance, we see that coming and living in parallel with 10. The big problem here is the telco guys. Got to get telco to go faster. It's the key to all of the other stuff that we're talking about in terms of delivery. And then one of my favorites, which I like to call the RDMA wars, is how are you going to deliver low latency? The bandwidth is important, but the latency is the most critical factor. As I like to say, it's one thing to have a Ferrari, but in traffic on I-5 in Los Angeles, it's the same speed as a Ford pickup truck. Got to get the rest of the traffic out of the way so the Ferrari can go where it wants to go. So, a couple of things here in terms of what we see happening. The data center is going to continue to evolve. You're going to see more change, not less. You're going to see innovation from places that aren't where we make a living. I think that when we start looking at the growth parts of the world, I know it's obvious to say China and Brazil and India and these other countries, but that's where it comes from. If you look at the history of humanity, it is where you have lots of people, and they're smart, and they're hungry, and they're aggressive, that innovation happens. I think you're going to see the classic barriers of nations change a little bit over the next decade, and you're going to see a lot of innovation come, but it's not going to come from the places that you normally expect. Users and data are going to triple, and you can leave that statement up there for the next 20 years, and it'll be true. Every 3 years, it's going to triple. Maybe not human beings, but the number of devices and the amount of data that's generated. The software-defined model, that's pervasive, going to happen, and it's going to happen across the entire infrastructure. And it's not about what we make, it's just about the reality of what you need to deliver in the world. You can't deliver all the things you want and have a static, rigid environment. Now, you'll see people like Cisco and Juniper and Brocade, they've announced their software-defined networking. And they're going to kind of do the same thing. They're going to put a nice layer on the outside. They'll still have their stuff on the inside. But even they're looking at it going, yeah, if we don't do this, they're going to go to the people who do. When you start seeing those players embracing this class of, I don't want to say openness because I think that's the wrong term, but this class of flexibility, for lack of a better term, that's when you know you've got something that really matters. Why? Because you scared them. Make no mistake, big companies drive on fear. They're paranoid. They want to make sure they keep their ship running. And when you see them embrace this, and it's not just Cisco, it's Brocade, it's Juniper, you know you got something here. And we expect this to fundamentally change everything. The technologies are changing at every level. I've talked about that. And this is my obligatory plug for us as a networking company. If you don't have networks, the stuff doesn't come together. And you're going to see the networks have incredible delivery in terms of being able to solve a lot of these problems. And they're going to have incredible complexity. Because when you try and do 40 things on a system instead of one, it's going to make it a little more complex. And that's going to be the biggest challenge as we go forward, is mastering the complexity so you can deliver simplicity in solutions. So I think that's the end of my pontification for the day. Any questions? And there was a deafening silence.
Well, you talked about the openness of the cloud and how this is becoming more important in terms of networking. What's your take on that? We're seeing a lot of proprietary protocols
I think it's just a question of when things become more open. Clearly, if you look at the variety of things. So, fiber channel, reasonably open. The problem is almost no one speaks the fiber channel language. It's sort of this arcane black magic and voodoo that we have off to the side. When you look at networking, sure, IP's open. But then there are all sorts of things they stack on top of it. If you look at FCOE as a great example, that's very closed. Yes, there is an open FCOE standard, but, again, who do you call at 2 in the morning when your server's down? And those are the types of trade-offs. So I think, again, it's going to be very application-driven. Ultimately, you're going to see everyone put some form of SDN shim on top of what they're doing. We all want to keep a certain level of secret sauce. We all want to have a certain level of proprietary IP to distinguish our products. But we are all going to be forced, just like Juniper and Cisco and Brocade were, to have a shim around it that at least gives people access to those services so they can determine how they want to use them. All right, well, he gave me the 5-minute sign about 3 minutes ago, so that's probably a good place to break. Thanks.